Heyo, I'm back. So we're gonna talk about interpreting slope today, grade 11s. All right, so I will just point out one thing before I start. This lesson is actually about 3 pages long, but I am going to break it up into 2 sections just for the sake of the video uploads, because I'm having a hard time uploading really long videos from my house. The Wi-Fi just isn't good enough, so I'm going to do this first page on its own, and then I will do the remaining 2 pages second. Okay, so just a heads up on that. All right, so let's do a couple bullet points here about the meaning of slope. So just a little bit of a review. You might have remembered this already, and we have a little bit talked about this, but if you didn't remember, here's your time to learn it. Okay, so the first thing we want to look at is a positive slope. And a positive slope means that the line is going up and, oh boy. Okay, there we go. Up and to the right. And we call this an increasing line. Okay, so this is a few terms that are important to know, and we have talked about them a little bit in class, but I know lots of us have been kind of in and out of school for a little while, so just to go over it. And an example would be m is equal to 2. Now again, remember that m is our kind of our variable for slope, and so we will represent slope by m most of the time. All right, then the other option is a negative slope. Okay, and as you can imagine, it's the opposite of a positive slope, right? So instead of going up and to the right, it's going to go down and to the right. Remembering always that we are measuring our slopes or reading our lines, I suppose, as we read. Like, so in English we read left to right, and so we're going to read our lines from left to right as well. And we call this a decreasing line. There we go. That's actually pretty messy. I'll just try and rewrite a little bit of that. Hold on 2 seconds. Decreasing. Yeah, it's a little bit better. Okay, and an example would be any negative slope, okay? And remember that a slope can be any fraction, whole number, or decimal, so it doesn't matter if it's a whole number like the first example or a fraction like the second example. We could also see some decimals, and we will, in fact, in this lesson. Okay, so, like I was just saying, we can express it as a decimal like 0.8, or a fraction like 1/5. I don't know, I'm just making that up, okay? And we remember as well that a slope of 0 is going to represent no change because the line is flat, or more accurately, horizontal. Okay, so the next thing we're going to look at is this example here, and the example asks us to classify each line as increasing, decreasing, or no change based on the slope values that are given. Okay, so each of these 5 values are slopes, and we're going to classify them as increasing, decreasing, or no change, so horizontal. Okay, so let's start here with m is equal to 3. So we can see that that's a positive number, right? Therefore, remember that those 3 dots that I just drew are the symbol for therefore, okay? And then we can say, since it's positive, this is an increasing line, okay? And then the next example, we're going to do the same kind of idea. Okay, I'm just going to change colors so it's easier for you to follow what I'm doing. So here we can see that negative, right? So that's an important feature here. I'm just going to highlight it. So if you look back on the notes, you'll remember what we talked about. So because it's negative, then, so therefore, the line is decreasing. Okay. Then the next one, we have 0.05, so again, it doesn't matter that this is a decimal, okay, that doesn't change anything at all. Just the fact that it's positive tells us that it's increasing. Okay, the next one, we can see here that this one's a little bit funny, hey? We have 0 divided by 3, and so remember that anything, when you divide 0 by anything, it just ends up as 0. Okay, and so because it's 0, then this is a no change line because the slope is 0, which means that the line is flat, so there's no change. Okay, and then last but not least, we can see there on the very far left that we have a negative slope. Okay, so again, I'm just going to highlight that because that's the important part. That's how it tells us that this is a decreasing line. Then we can just say negative. Therefore, I'm going to run out of space here, so I'm going to have to abbreviate. Okay, therefore it's a decreasing line. All right, the next one I want to do, and the last one for this short video, but only the first half of this lesson, I guess, is talking about shallowest and steepest lines. Okay, so I just use the same numbers as last time, except that I am noticing a little typo here. So if you guys want to just join me and cross out that 5, it's supposed to just be 0. Okay, I don't know how that happened, so we're just going to cross that out and to keep it the same as the first example. Okay, so remember that the shallowest line will be the slope closest to 0. Okay, so shallow means m, or slope, is close to 0. Okay, and a steep line, that's the other option, means the opposite, so m is far from 0. Okay, and I also want to remind you that the slope sign, okay, so whether it's negative like this or positive like this, that doesn't make any difference in the steepness. It's only how big the number is and how close it is to 0. Okay, so a number that's very close to 0, like for example 0.05, is going to be very shallow, okay, because the line value, the slope value, is very close to 0, whereas a number like 122 is much further from 0, so that's going to be a much steeper line. Okay, now when we do this kind of question, the first thing I would really recommend that you do is put every slope value into the same form. Okay, so here we have some whole numbers and some fractions, and of course some decimals. Now whole numbers and decimals kind of belong in the same family, right? Because 3, I could also express it as 3.0, it's kind of the same thing. But a fraction is a little bit different, and so I'm going to convert all of my fractions into decimals, and that will help us to see how big they are in comparison to the other. Okay, so 0 over 3, like we talked about in the last example, is just equal to 0. Okay, so that's a pretty easy one. But negative 2/3 is one of those that I would recommend that you memorize if you haven't already, because it's a little bit harder to kind of figure out on the fly. But it is equal to negative 0.6 repeating, so I'm just going to round that to negative 0.67. Okay, and so now that these are all in decimal form or similar, right, whole number or decimal, then we can compare them. So the question asks us to start with the shallowest and end with the steepest. And so since the shallowest is the closest to 0, we're going to look at what's the closest to 0. And because we actually even have 0 in this question, then that's definitely the shallowest line because it is literally flat. Okay, so 0 over 3. I'm always going to express my answers in the same form that they were given in the question. Okay, so even though we did this converting here to 0 and negative 0.67, I'm always going to express my answer in the way that it was given in the question. Okay, next up is 0.05, right? So we can see that's very close to 0, but not quite equal to 0. So that's going to be the next one. It's going to be a little bit steeper than a flat line, but barely. Then the next one we can see is negative 0.67. The reason I know that is because the other two that remain, 3 and negative 122, are both greater than 1, and negative 0.67 is still less than 1, so we have to do that one first because it's a smaller number, closer to 0. Then we have 3, which is clearly closer to 0 than 122, and then that leaves negative 122 for last, so that would be our final answer. Okay, so there we go. I will do another video right away about the rest of the lesson. Okay, talk to you in a minute.